Okay. Sorry that today we had to start a bit later. Thank you, Steven, for joining us, though it was late. Oh, I need to do this one. Okay. Follow me. Yes. Oh, okay. Okay. So today also we'll be going through some data and how to come up with different kind of graphs, charts, and basic things, just like those. Okay. And today we'll be using GeoGebra. Okay, you can see that over here. Okay, so please go ahead and download the height, weight, gender.txt file. I think you may have already downloaded that, and you may have been working on that. Okay, so let me go ahead and open this up. Okay, so I think I should first of all open the Excel, and then only we'll go for that. Okay, so yeah, height, weight, and gender. All right, same drill again here, delimited, tab, and next, and finish. Okay, so it will auto-populate everything. Okay, so I would want you to go to one website, which I am talking about, which is GeoGebra. It's a web tool, right? So there are many ways to go to there, but one of the ways that you can go is just type GeoGebra, algebra and geometry, geogebra.org slash classic has probability, sorry, has spreadsheet. Okay. geogebra.org slash classic has spreadsheet. Okay. The, what do we call that is sharp sign in music, right? And hash or ladder. I'm sure that it's okay. So this is the one of the way that you can go to that website. Okay, let me just post it over here in the message as well. Right? And once you go over here, then you can see that this is just like Excel. Okay, you can see the cells divided just like as if we were trying to work on Excel. That's fine. So this is one of the way that you can enter geogebra.org. Now, another way that you can enter this classic spreadsheet is that I have linked chapter 2, entire exercises, homeworks, and quizzes of chapter 2 to this website. Okay, so if you go to any of the homework or quiz in chapter 2, then you can see that if you try to enter over there, let me go over there. Okay, then there is this resources, and you can see GeoGebra spreadsheet. Okay, you can either go for open in a sidebar. That means it will just hover around in your in this interface. If you do that, yeah, this will just hover around. You don't there is no option to pull it outwards or anywhere. Okay, and if you go through this sharing option, this one, okay, then it will just take you to the website. Okay, so there are these two ways to go towards GeoGebra spreadsheet. Okay, all right. So now let us. So I hope you have already have gotten into this website, geogebra.org/classic has spreadsheet. Now let us copy the data and paste it over there. Okay. Okay. So first of all, just go ahead and copy, let's say 20 or 25 data from this website, so from this data set. Okay. Let me copy 25 data points. Okay. Control C. And paste it on this spreadsheet. Okay. Now, why I'm using GeoGebra is there is this plot known as stem and leaf plot and box and whisker plot. They are much more easier to work with in GeoGebra than in Microsoft Excel. Okay, we'll be doing that in Microsoft Excel, but you will see that you don't have any option to do that in Microsoft Excel. However, for box and whisker plot, you can do it, and it might be much more reliable in Microsoft Excel, but it is way easier in GeoGebra. Okay. Similarly, there is another graph known as the histogram. Okay, it's very troublesome to figure out histogram chart in Microsoft Excel. So that's why we are using GeoGebra. Okay. So now, I hope everyone has copied the data points. Yeah, you can go up to 100 or something. That's up to you. But I just chose 26 rows, one including the header. Okay, the first one is header, and I copied this 26 rows and pasted it over here in the Excel worksheet. Okay. So first of all, stem and leaf diagram. Okay, let's go for that. Stem and leaf diagram. Okay. If you go to chapter 2.1, then stem and leaf. What happens is, for stem and leaf diagram, we take the place values of numbers. Okay, we take the place values of the data and separate those as stem and leaf. Okay, the place values of data. Okay, I think I should go for paint. Okay, so for stem and leaf diagram, we go for place values of discrete data, or yeah, discrete data usually. Yeah, just let's go for data. Usually this is discrete. Okay, and usually what happens is, let's suppose you have data something just like 21, 29, 30, 25, 24, something just like this. Then the unit tens. Okay, so each of the data points, each of this data has their own place values, right? If you look for this 24, then you can see that this 4 is in the 10th place, and this is, sorry, unit, and this is unit, and this is 10th, right? And here also this is unit, and this is 10th place, and so on, right? And since these are double digit numbers, so we will consider the unit values to be the unit place values to be the leaves, and 10th place values to be the stem. Okay, so this is straightforward, and it will help us to read the data quickly. Okay, so the main idea behind this stem and leaf graph is just to read and understand the data quickly. Okay, so and you can easily figure out how many data are there. For, let's suppose in this scenario, you can see there are 1, 2, 3, 4 data in within below 30, and one data at 30th place, right? We can see in that way. So, and if you look at the book, then you can see how the stem and leaf is going to work. Okay, if you just look at example number 2.1, then stem is 3, 4, 5, 6, 7, 8, 9, 10. Leaf is 3, 2, 9, 9, 3, 5, 5, 1, 3, 7, 8, 8, 9, 9. So how would you study this one? Okay, how would you look at that is, if you look at the stem and leaf, then you might want to group them together and read it in this way. 3 and 3 makes it 33. Okay, 4 and 2 makes it 42. 4 and 9 makes it 49. 4 and 9 makes it 49, and so on. Okay, so this is how it goes. Okay, and similarly, if you go for 9 and 0 makes it 90. 9 and 2, 92. 9 and 4, 94. 9 and 4, 94. 9 and 4, 94. 9 and 4, 94. 9 and 6, 96. And 10 and 0, that's 100. Okay, so this is how we read this data, and you can now clearly see how many data are in the 30s range. Okay, there is just one data point. How many data points are there in 40s range? That is 3 data points. And how many are there in 60s range? That's 1, 2, 3, 4, 5, 6, 7 data points, and so on. Okay, now you don't have an option to go for stem and leaf plot in Microsoft Excel. Okay, I have never seen that, and you can just take a look about how you can go for that. Yeah, I have never seen that. Okay, yeah, I have never seen that. So that's why I'm going to GeoGebra to work on that. So let me just go for height. Just choose one. Okay, choose one column, and go for this bar-like diagram, okay? Small icon over here. I hope everyone can see this, okay? Go for this bar-like diagram and go for one variable analysis, okay? There are one variable analysis, two variable analysis, three or more variable analysis, okay? We can see that. So one variable analysis, click on that, then you can see that it automatically gives us histogram and so on, but you can click on this drop-down menu and go for stem and leaf plot, okay? If you go for that, then you can see how this stem and leaf plot works, okay? So now you can clearly see that 5 and 6, okay? So the data set ranges from 50s and 60s, okay? You can see in that way, okay? So most of the data set, most of the data point lies within the range of 50s, right? Okay, the height is 50 inches and so on. And 60s, there are just 5 of them, all right? Okay, we can go in that way. All right, so that's fine. Okay, so this is how we might want to learn about how we might go for stem and leaf plot. Now, another interesting thing is that you can see lots of buttons over here, and you can make use of those buttons as well, okay? So, yeah, I will talk about this plus 1 and minus 1. They are there to change the place values, okay? We will see in another example. And similarly, if you go for this summation x, this button, then it will give us the mean, median, quartiles, and maximum values, and standard deviation, and so on, okay? So the total number of data points are 25, mean is 57, standard deviation is 3.00332, this is variance 3.0957, sum of all the numbers, all the data points is this much, and their squares is this much, minimum value is this much, Q1, the first quartile, median, third quartile, and maximum value is this one, okay? So that's fine. And it also will ask you if you want to export the data and so on, okay? I don't know how to get rid of this one. This is really a bug. Yeah, okay, let it be. All right, so that's fine. And if you don't want to, if you want this to get hidden, then you can just click over there on summation x, okay, this sleeping m x. Okay, so that's one example. So let me go to another example for stem and leaf, okay? If you click on this column B, the weight, okay, then you can see how stem and leaf would work, okay? And again, go for one variable analysis. Yeah, now you can see this kind of thing, okay? So here, you can see that we had 3-digit numbers, right? Each of the numbers were greater than 100, right? But if you look at the stem and leaf plot, then you can clearly see that this is saying 1, 4, 14. Okay, that's fine. There is 14, but where is 142? We can't find that. Just like there are some persons whose weight is 164. We can just find 16 and nothing else, okay? So there is some kind of, some data is hidden or being ignored over here, okay? So for that, we need to change the place values, okay? Just play with this one. Go for negative, and then it will show you, okay? If you click on -1 means go for farther left place value. That's what it is saying. So we are getting our stems to be 14, 15, 16, and so on, okay? I hope that makes sense. And if you want to reset that to previous way how the stem and leaf plot was written, then you can go for +1, okay? And then you can see how it is. Now it doesn't make any sense, right? So it is always advisable to play around with those place values, okay? +1 and -1s. Okay, so that's it. All right, any questions, people online? Joseph and Steven? Okay, so if there is no question, then that's fine. Let us move on, okay? Now, another thing that I would like to work on is, okay. So let me go for this. Box plots, okay? I will go to box plots right away. Since here, I think I might be able to help you a bit faster, okay? So that's why I want to go for box plots, okay? So box plots, Okay, box plots. Okay, so box plot here, let us assume that your data is represented by a rectangle, just like this one. Okay? Let's suppose your data is represented by a box, just like this one. Okay. Now you can clearly say that you can say that this point is the minimum point. This this edge, the leftmost edge, is the minimum, and let's suppose this rightmost edge is the maximum. Okay, so we are assuming that all of our data points lies within that box. Okay, and minimum is the left one, left side. Okay, and the maximum is on the right side. Let us chop this box into two pieces. Okay, let us chop this box into two equal pieces. So this would be the thing. Okay, so I'm technically, yeah, nearly at the middle of the data point. Okay, and again, let me furthermore subdivide this data set into 4 equal parts by chopping down the first half and the second half. Does that make sense? Okay, so you can see that below this point, okay, this is the point. Below this, we have 50% of the data, and after below this, we have the 100% of data, right? Okay, so we can think in that way. And we say that this point would be known as the median. The centermost data would be known as the median in this situation. Okay, yeah, mean also would be called as the centermost data, but as I'm telling you that, as I have told you previously, very superficially, that median, mean, and mode are the 3 central values of a distribution. Okay, of a data set. Okay, so so we have chopped down the entire data set into 2, and the middlemost point is the median. Okay, and now median, or yeah, I will come up with another name for these things later on. Okay, shortly, within a couple of minutes. And let us chop this 50% of the data down the median and 50% of the data up to the maximum into 2 equal parts. Okay, so that would be somewhere around here. Okay, and this would be somewhere around here. Would be somewhere around here. Okay, that's fine. Now the entire data set has been divided into 4 parts. Okay, the entire data set now has been divided into 4 parts. Okay, and you can 4 equal parts, I mean. Okay, all these parts are equal. Now here you can see that below this point, 25% of the data lies below that point. Okay, so this point is known as quartile, first quartile, Q1. We will represent that as Q1 quartile, first quartile. Okay, Q1 is first quartile, and below first quartile, 25% data will lie. Okay, first quartile, and below this number, the median, we will say that this is Q2. Okay, below Q2, 50% of the data will lie. We will say this is second quartile, and below this third line, 75% of the data will lie over here. So let me just this one. Yeah, this is Q3, and below this Q3, you will see that 75% of the entire data lies. Okay, so this is third quartile. Okay, so that's it. So we have 5 different values over here. Okay, first one is the minimum. Second one is the Q1. Below Q1, 25% of the entire data lies. And the third one is Q2. Below Q2, 50% of the data lies, or Q2 exactly divides the distribution into 2 parts. Okay, Q3 is the fourth point. Okay, below Q3, 75% of the entire data lies over there. Okay, and finally, the fifth one is the maximum point. Okay, so we will think about this in this way. Okay, and yeah. Okay, so let me just make this thing a bit nicer so that it will be very helpful for me to Okay, so that's fine. That looks good. Okay, so this is fine. Now, these 5 numbers that I was talking about will be known as the 5-number summary of the entire data, which is very crucial and very important. Okay, so 5-number summary. So I'll write down. Okay, so this one is 5-number summary. And we will later on learn how to find out these quartiles. Okay, first quartile, second quartile, and third quartile. Minimum, Q1, Q2, Q3, and maximum. Okay, so these are the 5 numbers that represents the entire distribution. Okay, so this is minimum, this is Q1, this is Q2, this is Q3, and maximum. And Q2, median, they are the same thing. Okay, Q2 and median, they are the same thing. Okay, now what mathematician, these statisticians did was they just erased this portion. Let me just erase this, and let me just erase this portion. Here also the same thing. And there's a nice logic why they did so. Okay, since most of the data lies within Q1 and Q3, okay, so that's why they erased that, and they joined all these things, minimum and Q1 in this way, and maximum and Q2, Q3 in this way. Okay, now this graph is known as the box plot. Okay, so this graph is known as the box plot. If you yeah, and so in Microsoft Excel, if you try to go for box plots, then it will show you vertically. Okay, now if you look onto stock market or any indices, okay, stock market indices or cryptocurrencies or forex indices or anything, those kinds of commodity markets, then you will see a vertical candlestick patterns, which is eventually the derivative of, which is actually the derivatives of this box plots. Okay, so minimum is this value. Okay, maximum is this value, and most of the value lies within Q1 and Q3. Okay, in between Q1 and Q3. Now, nothing is exact. Okay, means nothing is perfect. Okay, this may be skewed. Means it may be to this Q2 may lie towards. Okay, it may be closer towards Q1, or Q2 may be closer to Q3. That could happen. Or this length may be greater than this length. Okay, the distance between minimum and Q1 may be lesser than Q3 and maximum, and so on. There could be lots of things happening over here. Okay, all right. So that's a description of box plots. Okay, by working on box plots, you get 5 numbers, and those 5 numbers, minimum, Q1, Q2, Q3, and maximum, they will give you some idea about the data, how the data is spread, and so on. Okay, all right. So that's all about box plots, and this is how the box plots are created. Okay, now I hope you understood that. Okay, so any questions until now? Okay, so this is fairly straightforward to understand. So I hope you got it. Okay, now let us head over to GeoGebra and work on our plots, just to make sure that we are and let us come up with those box plots. Okay, so let's go for that. Height, weight, and gender. Yeah, just for yeah. So I just want to treat all of this data in a similar way, and just to prove some of my points, or just to make sure that there could be lots of what do you say, lots of things that you can do. Okay, or you may want to expect while drawing this histogram, this box plots. So I would want you to select all of this and go to this one variable analysis to go to this bar chart like thing and go for multivariable analysis. Since we are talking about 3 different variables, right? Height, weight, and gender. So this is how it looks like. Okay, this is how the graph would look like, and you can see that the column A, the height for the box 1. Okay, the box plot for height column height is, you can see the median is very close to the Q1. And here also, median is trying to go towards Q1 and so on. And you can see that the distance between the minimum and Q1 is lesser than the distance between Q3 and maximum and so on. And for gender, you can see there is only 2 gender. Okay, this data is considering only the binary genders. So we don't have a box plot. It's all there. Okay, it's just a simple rectangle. Okay, so that's fine. So this is how it goes. And you can see that all these points are plotted in this way. And you can see the x-axis is denoted in this way. Okay? So our data for height ranged from 50s to 60s, right? So that's why it's all in there, 50s to 60s. And the weight ranged from 120s, 140s to 160s, right? So it is from here up to here in that way. Okay, now, yeah, this is way too squeezed. So let me just take height and weight and try to make a come up with another box plot. Okay, just to show you how things would look like. Okay, so this is the way how it would look like. It is much more nicer since that's just binary outcome. So we are not considering that for box plots, and it will look something just like that. Okay, so that's fine. All right, so this is it. Okay, and in real life situation, if you want to look for how the stock or commodity market or cryptocurrencies would look like, then you can go for, okay, let me just see, yeah. Okay, let me just go for Microsoft, okay? Microsoft stock, okay. I'm not going for Microsoft, MICROSOFT, okay. Microsoft stock, and let's see how it goes. Oh, it doesn't have that. Hold on, I wanted to show you the candle pattern. Right, so, okay. All right, let me go for Apple. And look here, the candle pattern. Okay, so this is how it looks like, right? So you can see that Apple, this stock of this Apple is, you can see that these green ones means it's going up, and the red candles, it means going down, right? These are actually box plots, but the only thing different between the box plots that we learned and how they are using over here is that they do not have a minimum and maximum over there. Since the price can fluctuate quite wildly, right? Since we don't know what individual investors look for, so that's why they don't have minimum and maximum cap and so on. So here the green candle or the green box plot would mean that this point would be the lowest or minimum price. This point would be the highest or maximum price, and most of the trading happened for this candle or for this price chart, I think in that day. So I was looking for December 10th. Okay, you can see that the price, the Q1 of the price was 175.16, and Q3 was 179.49, and so on. Okay, it will go in that way. Okay, so this is how it looks like. And it is also saying that for this red bar also, it's the same thing. It started to sell off from the point nearly 182 and sold off until 175.58 and so on. Okay, so that's how it has been used. Okay, and also a few things to note over here is, let me go for this one again. Since there may be some outliers in our data, okay? Sometimes there could be outliers. There could be way higher data point and way lower data point. In that case, some of the data points could lie somewhere around here, okay? Or here, if this is very low, okay? Just look at this line, and you can see that some of the data points may lie in this case, okay? Since that's an outlier, it doesn't follow the usual pattern of the data. So that's why they are pushed further to the left or further to the right, okay, in that way. All right, so that's what should be known for box plot. Okay, so that is it. All right. Okay, and you can clearly realize the 5-number summary over here. Okay, if you just go for summation x, then it will show you everything. Now, this is what I don't like about GeoGebra is it doesn't let you to scroll all the way down. Okay, so you can see that there are total number is 25. There are 25 data sets. Mean of the first column is 57. 151.72 is the mean weight. Standard deviations are given. The variance is given. Minimum, Q1, median, Q3, maximum, all are given, right? Okay. So maximum for the first data set is, for the height is 64, and 164 should be the maximum for the second data set weight, right? Yeah, it is. I don't know why they haven't fixed this bug, and everyone is complaining for that. Since this is open source, someone must volunteer. They don't get paid, so it doesn't get updated. So that's the main drawback for using open source software, unless and until you are a good programmer that you can fix the bugs yourself. Okay, so that's fine. I hope does this thing. Okay, now doing this thing will. Okay, so that's fine. So now we can see the maximum. So, all right. Okay, so that's it. And I think we can drag it down. Oh, okay, so that's why. All right. Now I should stop criticizing. Okay, they're doing this for free. They don't get paid. This is open source, but I'm grateful for that. Okay. All right, so I think you can go over here and see in this way. Okay, so that's it. Okay, it gives us everything that we want right away. And what else is there? Okay, so that's fine. Right. Okay, histograms. Okay, box plot. Okay, let us go for a bar chart now. Is there any question or concerns for the people online? Please let us know. Okay, so now while learning about this box plot, we learned many things. Okay, just like 5-number summary, it gives us nice picture of how the distribution would look like, and that will help us to understand many things about it. Okay, and okay, so now let us go for one nice graphs, which are known as the bar graph. Okay, line graph if possible. Let's see. Okay, line graph and bar graph. So these things are very easy. Okay, now you must understand that whenever you are trying to draw a graph, okay, whenever you are trying to draw a graph, make sure that you have a title, nice title, which represents what you are trying to say in the graph. It should have legends if necessary. It should have x-axis titles, x-axis and y-axis, their names, and all the necessary things. Okay, it should have those kinds of things. All right, so now let us go for bar graphs. Okay, let us again go for the same thing. Okay, let me choose the first column and go for one variable analysis. Okay, so go for that, and it will give us histogram by default. Now let me go for the bar chart. Okay, so that's fine. Let me go for bar chart. So this is how it look like, how it would look like. Now, basically, what we are doing over here is, okay, if you look at the data that we collected, the 25 people, their height and weight and gender, then this is the way how the bar graph would look like. Okay, but you need to realize that there are one person whose height is 52 inch. Okay, there is one people whose height is 53 inch, and so on. There are 3 people. Okay, there are 3 people whose height is 54 inch. There are 4 people whose height is 55 inch, and so on. Okay. Now let me try to see if I can furthermore make this graph a bit nicer. since you can see that this bar graph looks bland, it doesn't say anything, right? It doesn't have title, it doesn't have anything. However, you might want to export this thing and paste it in your Microsoft Word and later on label that according to how you want. Okay, so that's the drawback for here. Okay, copy to draw. What does that mean? Export it as picture. Okay, so let me see how it looks like. Okay, it looks like this. Okay, that looks fine. Okay, and you can just copy and paste it in Microsoft Word and later on write down the title, what goes in x-axis and what goes in y-axis and so on, right? And now I would want to make this bar chart much more easier. Okay, so here you can see that in this bar chart, we don't have much variation in data set, right? But let's see, if you have hundreds of variations, or there could be hundreds of variation, one bar may represent 223, another bar may represent 356, and those kinds of big numbers, big in comparison to those, then I would prefer to have some numbers on top of each bar, which will represent the height of the bars. Okay, so that's my preference. That's how I would look like. Okay, so that's fine. Yeah, and this is what I was telling. Okay, you can go for frequency table as well. Okay, so how do I did it? Is I just went for this settings, and the bar chart came in that way. Okay, and frequency table, you can take it off or on. Okay, and you can see how the frequency table would look like. Okay, and let me see if there's anything. Okay, all right, you can play around with the dimensions of the graph. Okay, that's up to you. And also sometimes it's very easier for people to look on. Okay, if we go for show grid. Okay, if we happen to activate the grid, okay, that would be better. All right, so that's fine. And you can see how this now this doesn't have that kind of thing. Okay, now you can see how the frequency is distributed among all the data points. Okay, all right, that looks fine. Yeah, 52, 1%, 53, 1%, 54, 3%, 55, 4%, and so on. And everything is shown in that way. Okay, so this is the data which is used to plot this bar graph. Okay, so that's it. All right. Okay. Okay, that's fine. Now let's see if I can find any other things. Okay, so this is the way how we come up with bar graph. Okay, and frequency table is quite essential, right? Does that make sense? Frequency table is quite essential, and they have recorded over here on the bottom, okay, how many people had height 52 inches, just one. We must record that at first. Okay, that will make things easier and it will help us to graph the data. Okay, so that's fine. And yes, okay, so that is it. Is there anything else? Okay, mean, median, quartiles, everything is there. What is this? So data. All right, that's fine. What is this? Okay, all right. Okay, yeah, I was talking about this one. All right, that looks fine. Okay, now let us go for dot plot in this case. Okay, if we go for dot plot, it doesn't do that. Okay, this was not the thing what I was looking for. Bar chart, normal quantile plot. No, this is not what we want. Box plot. Okay, now so that's how we go for bar chart. Okay. All right. So that's how we go for bar chart, and coming up with this line graph. I don't think we have line graph over here in. Oh, we should have line graph over here. So let me go for that. Okay. So for line graph, you choose 2 columns. Okay, and go for this 2 variable regression analysis, and you will see the line graph in that way. Okay. Actually, this is scatter plot, and we won't be able to get a line graph in this case. Okay. Line graph is only for this kind of situation. Okay, so let me come up with my own. Okay, so here, insert column. A. Where did it go now? Oh. Okay. All right. So let me just go for this one, and let me just write down in this way. Okay. So person number of person, and just let me write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let me just go for only 10 people over here, and let me choose these two things. Okay, all right, let me do that. And now let us go in this way. Let me go for 2 variable regression analysis, and you can see how it would go. Okay, then schedule plot. Okay, then also it doesn't do anything. Okay, so can we go for 1 variable analysis? Bar chart, box plot, histogram. No, it doesn't do that. Okay, leave it. Okay, I don't think we will get a line graph over here, since line graph is only for that case whenever that is for time series. Okay, what was your height when you were 5 years old, 6, 7, 8, 9, 10, and so on, right? So your average height at the age of 5 would be something. Okay, let's suppose 45 inches, and so on. Okay, and so on. So for that case only, we will get that kind of value. Okay, yeah, we can make a quick data set just like for that, and we can see on that. Okay, year and height. Okay, so let's see. Okay, so what was your height in when you were 4 years old? 5, 6, 7, 8, 9, 10. Okay, so let's go for that, and then let's see. Let's suppose 45 inches, 49 inch, 53 inch, 55 inch, 8 inch, 6 inch, let's say 57 inch, and 58 inch. Okay, let's try to look at that, and you select this, go to recommended charts, go for all charts, and try to go for line graph. Okay, and then it will give us the, and then choose the appropriate one. I don't think this is the one that we want to choose. We will just go for this one, since yeah, so that's it. Right? So this is the line graph that we are talking about. Or something just like, let's say, what was the, let's suppose you work for a restaurant, and as a part of your tips, how much tips did you get each day? Then you can draw you can go for that. You can come up with similar kind of thing, similar kind of data chart, similar kind of chart for that kind of thing. Okay, that kind of situation. Okay, so yeah, day and tips dollars. Okay, so you can say that day 1, day 2, day 3, day 4, and day 5, and let's suppose your 6th day was off, 7th day, and 8th day, and so on, right? Suppose you got $5, $7, $10, and one was a lousy day. You just got $3 and $5 and $8 and $12, and so on. So now if you go for that, then you can see there is certain nice pattern that you might want to think about. Okay, so let me go for recommended charts again here. Yeah, and you can see how it looked like. So look, it is not showing anything, right? I think it's interesting. Okay, I need to go for that one. Okay, so that's fine. All right, so this is the chart that you might want to look for. So this is also known as time series as well. Okay. All right, so these are the short descriptions of what we can do in what we can do for graphs and so on. Now, as I have been telling you, yeah, nice representation of a graph. Nice means not fancy. Okay, it must have all the information that you want. and it must say what you mean to say, okay? And always be careful about what you say whenever you are whenever you are presenting a graph, right? We must not hypothesize something. We must assume that statistically, okay, this is true and this may not be true, and so on. We can say that, but we can't assert something. We can't be certain of something, okay? We can't do that, okay? That's not our job. And if we assume something, we must state that clearly. So that's what I mean. Okay, so that's all about line graph and so on. Okay, and as I was telling you, how does okay, so is there any question or concern? I'm talking too much. I haven't given any time for you to speak. If there is any question, let me know. Okay, now if we go to box plot for box plot in Microsoft Excel, then let's see how it look like. Okay, so here let us choose all those 25 data sets, okay, and go to insert and go for recommended charts, all charts, okay, and go for this. Where is that? Where's the box plot? Oh, it's over here, right? Box and whisker. Okay, and then click on OK. Then you can see how it is looking like. Okay, so can you see this? Okay, so all right. So now if you look at this one, then you can see that this blue one represents the height and the orange one, orange box, looks like weight. Okay, and you can clearly realize what is what. Okay, you can certainly understand which points are the minimum and which is maximum, what is Q1, Q2, Q3, and what do you think that cross means? That cross sign means, what does that mean? Can you guess? Well, median is that line in between, right? So what is the another central value of the distribution? It is, of course, what is the central value of the distribution apart from median? Median is one, another is mean, right? Or average. So this cross that they are showing over here, it is the mean or average, okay? So that is another representation that we may want, we can see whenever we are plotting the graph, okay? So if you go for some sophisticated softwares like R, that's a very advanced statistical package and requires a lot of coding, then you can see similar kind of diagram as well. Okay, but GeoGebra, it doesn't do that. Okay, it's a very, it's not that sophisticated. It just gives you whatever the basic things and basic ideas only. Okay, so in Microsoft Excel, the mean are pointed by this cross sign. Okay, and if you hover on top, I think it should show that one. Let me see. Okay, the minimum value is 141. Q1 is 147. Q2, oh, it doesn't do that. Q2 is 151. Q3 is 157.5. Q4 is, our maximum is 164. That's what we know. And 151.72 is the mean, okay, in that case. All right, so this is that's a very slight difference. Okay, so that's fine. All right, so that's it. Okay, any questions until now? All right, so we have covered stem and leaf graph, line graphs, bar graphs, box plot in both Microsoft Excel and over there. Okay, now let us go for this histograms, frequency polygons, and time series graphs. Okay, time series, I think we have already discussed about that, but we will move on further. Okay, so let's go for histograms and polygons. Now, histograms, first of all, we need to come up with frequency table. Okay, and then we will look on to how it looks like. Okay, and histogram, it is not that easy to figure out in in Microsoft Excel. However, it will give us some idea in GeoGebra. Okay, so let me go for one variable analysis, and look, histogram will be just like this. It's just another form of bar graph, but the rectangles, they are attached to each other, means they remain side to side to each other. Okay, and what we need to realize over here is we talk about intervals, not only for the discrete. Okay, not the discrete values. Okay, so if you go for the frequency table, where is that? Now, where is the frequency table? A while ago, there was a frequency table, and what is that? Oh, here it is. Okay, so frequency table. Let us talk about that. All right. So if you go for, let's suppose, bar chart, then you can see this is the frequency table, right, in this way. Okay. But what happens is the frequency table for histogram will be very different. Okay, it will be according to what you choose. So that's why I think Microsoft Excel doesn't want to hypothesize and give you histograms. Okay, or they haven't set up a default way to come up with histogram in that way. But for histogram, yeah, look for the difference. Okay, so this is these values are discrete values. However, for the histogram, you can see the values are continuous. Okay, 52 to 55, 55 to 58, 58 to 61, 61 to 64, and so on. Okay, and if you look at these values closely, then you will see that, okay, you should say that this 52, 55, 58, 61, they are lower limits of the each interval. Okay, and the right hand side, okay, whatever we have in the right hand side, 55, 58, 61, 64, they are the upper limits of those intervals. Okay, so here by default they are choosing that 3 is the width of the interval. Does that make sense? Now it could be 5 or 10 or 20 or something just like that, but always make sure that whenever you are creating a histogram, make sure that you have at least 5 or more bars. But here you can see that if we try to make 5 or more bars, then things will be a bit messier. So they haven't gone for that. Okay, they have just gone for 4. That's fine. Okay, and you should be well aware of yeah, and so that's why they have taken 3 to be the width of the interval. Okay, and since we know that 52 is the lowest one and 64 is the highest one, so that's how it is taken. Okay, so now lower limit always falls in the interval, but upper limit does not lie in the interval. It lies above that class. Okay, so this 52 to 55 won't contain 55. Does that make sense? Okay, but this 55, if there's a height 55, if the height is 55, then this one will be counted in the second class interval. Does that make sense? Okay, it won't be counted in the first class interval. Okay, so that should be the that's the only thing that you need to realize. And then you can see that for 52 to 55, you will count 52, 53, and 54 only. 54, there are 254, 153, and so on, and 154. There are 5 of them. Okay, yeah, this is a bit tedious. However, the computer is doing everything for us, so that's fine. Okay, similarly, 55 to 58, you will count 55, 56, 57 only. You won't count 58. Okay, and similarly, for 58 to 61, you will count 58, 59, 60. You won't be counting 61. Okay, and so on. All right, so that's it. Okay, so that's how we go for histogram. And 52 to 55 is written down in this way. So 52 up to 55, yeah, that's the width of the rectangle, and height is the frequency, right? There are 5 people whose height is from 52 to 55, so that's 5 over here. Okay, similarly, there are 11 people whose height is from 55 to 58. So that's the highest rectangle in this histogram, and so on. Okay, this is how we draw the histogram. Okay, and then so after you have drawn the histogram, then it is always necessary to come up with frequency polygon. Now, frequency polygon will have many geometrical ideas and applications if you really want to dig into it. But frequency polygons are very easy to draw whenever you are working with histogram. Okay, so first, to get frequency polygon, you first need to draw histogram and find the midpoints of each of the rectangles. Okay, this is the midpoint, that should be around 53.5. So this should be the midpoint, that should be around 56.5. Yeah, something just like that. This should be the midpoint, that should be nearly 59.5, right? And this would be 62.5 or something, should be the midpoint. And you go for one more midpoint over here in the right hand side, beyond the rectangles, and one midpoint towards the left of all the rectangles. Then if you click on this frequency polygon, then see how it looks like. Okay, so this is the frequency polygon. Then you can see that some of the area of the histogram has been ruled out, means they have been left out. Okay, this portion has been left out, this portion has been left out. However, you can see that this portion, this one, and these triangles are overcounted, right? So actually these triangles are congruent to each other. Okay, this triangle, the overcounted triangle and ignored triangle, they have the same area. This one and this one, they have the same area. This one and this one, this triangle, they have same area. This and this, they have same area. This one and this one, they have the same area. So basically that frequency polygon and the histogram will give us the same area. So that's what I'm talking about. Okay, right? And there is nice proof of that, but we don't need to go for that. Okay, all right. So that's frequency polygon. Okay, any questions until now? Look, everything is done by computer, so you just need to understand what is this. All right, though I haven't gone through frequency table, but you should understand that we try to keep the data in the table in a nice way, in a nicer way. Okay, so that's what we are doing over here. Now again, let me go for this weight and try to see how it looks like. Okay, analysis, and this is histogram. Okay, looks fine. And what is this? All right, histogram data. Hold on, this one. Okay, so that's fine. Okay, right. Graph, so grid. Okay, and histogram class set manually, normalize. If frequency table is also there. Okay, and frequency polygon. All right. So this is another histogram that we are talking about. That's the histogram for the weights. And you can see that the interval is taken as, now you can clearly realize what is the minimum and maximum by looking at this one. Okay, so the minimum value was 141, maximum is 164. Okay, minimum and maximum. We don't want our histograms to have more than 10 rectangles. Okay, so and we try to restrict around 5 to 8. So that's what we try to do. Okay, so if you go for that, then this one is going for 141 up to 145.6. That means 4.6. 4.6 is the width of the rectangles. Okay, 4.6 is the width of the rectangle. And yeah, so the intervals are chosen in that fashion. Okay, 4.6, add or subtract. 4.6, add that to 141, and then again, and it will go up to 164, right? And you can see how the frequency polygon looks like. And it's the same idea. Okay, so that's fine. All right. This is how you draw histogram in GeoGebra. Okay, but it's very tedious to draw histogram in Microsoft Excel. Okay, we need to go for 4 or 5 steps, and then only we can come up with that. But if you find a better way to come up with histogram in Microsoft Excel, then let me know. Okay, I'll be happy to see that. Since while I was teaching a different course of statistics, we had to go through those kinds of things, and I tried to go for histograms for that, and we had to go for many steps to do that. Okay. All right, so I think that's all, and I am talking too much, so that's it. All right. Measures of the location of data. What is this? Oh, okay, percentile and so on. Okay, so I think this is all, and I should stop here right now. And next day means next, on Monday, we'll be going through all of those things like mean, how to find that, median, how to find that. We will do some calculations. Okay, I will show you how to do that, and eventually, after you have understood the concept, then you will be working in either GeoGebra or Excel, whatever, whichever platform you like. Okay, and it's very straightforward. We will be talking about quartiles, skewness as well. Yeah, skewness and so on, standard deviation, variations, and so on. Okay. All right, so that is all for today. Thank you so much for joining me. Despite it was late, thank you so much for joining me, and see you on Monday. If you have any questions or concerns, please let me know. Thank you so much. Bye-bye. Okay, let me close the screen, okay? All right. Thank you, Stephen. Bye-bye.